we're looking at this here first is determine which quadrant each angle lies in. Now, the best thing I would say with this is to get it between 0 and 360 or 0 and 2 pi, whichever one you're more comfortable with. Because straight up is 90 or pi over 2. Straight across is 180 or pi. Straight down is 270 or 3 pi over 2. And then we get back to 2 pi and 360. So I'll look at least one of these with radians, one of them with degrees. If you all need to see another one, we can go back to it. The first one I'm going to look at is 7 pi over 3. Now, if we talked about this in radians, well, that is bigger than 2 pi. So I can plug it in a calculator, 7 pi over 3. And I'm going to subtract 2 pi from it until we get between 0 and 2 pi. Well, it tells me that it's pi over 3. And on the unit circle, pi over 3 is in the first quadrant. So it's quadrant 1. Now, the other option is to convert it to degrees. And to do that, we would multiply it by 180 over pi and get 420. And do the same thing with degrees. Since this is bigger than 360, we would subtract 360 from it and get 60 degrees. Well, 60 degrees is between 0 and 90, so we're still in quadrant 1. Number 3 is still in radians, so you could convert that to degrees. You're just multiplying that decimal number by 180 over pi, seeing what you get, and then going from there. Now, negative 295 degrees, well, do we want to look at 4, 5, or 6? 5, 8,176 degrees. Now we can definitely say this is bigger than 360, so I can subtract 360 from it. We get 7,816. Well, that's still bigger than 360, yes? Now I could type that in and then say minus 360, but a nice little shortcut is I can hit minus 360. A and S is just the previous answer, so it'll grab 7,816, and I can hit enter. And I can keep hitting enter because it's going to keep grabbing the previous answer and subtracting 360 from it. And obviously we just did this multiple times. 256 is now finally between 0 and 360. So I just lost 256. Exactly, because 256 is between 180 and 270. So it is quadrant 3. So on both of these here, on the answer key, I put Q3, Q1. You can put it as Roman numerals. You can put it as a number. I will take either, as long as for number 1 you don't put Q2, 3, or 4. And for 5, as long as you don't use 1, 2, or 4. As long as you use the correct number for that quadrant. Questions on this here? And I mean, it also works with negatives, but instead of adding 360 subtracting 360 or subtracting 2 pi, we would add it to get it back up between 0 and 2 pi or 0 and 360. Questions on this here? Find two coterminal angles, one positive, one negative. Again, for these here, we're either adding 2 pi or subtracting it, or adding 360 or subtracting it. So negative 25 pi over 18. Here, we can add 2 pi. Because if it's a negative one that we're given to start with, I would try adding it first. We get 11 pi over 18. So that's our positive. Now, it might, because if we hit enter, it's not actually going to do anything. It needs A and S to do that multiple repetition. But I could come up here, select it, or retype it in. and say 25 pi over 18 minus 2 pi is negative 61 pi over 18. And that's it. Or add it. Do we want to look at 9 or 10? 10. Now with any of these here, I always start out doing the opposite of whatever the sign is. And it's not a mandatory rule. Because for negative 510 degrees, we could subtract 360 first, or we could add 360 first. We could do either. I always do the opposite just in case the angle is bigger than twice 2 pi, or smaller than it, to where if we did this here, I added 360, we get negative 150, yes? Well, adding it didn't give me a positive angle. It gave me another negative, yes? And the reason I do this is, okay, that's negative. I can do plus 360 again and get 210. So we have our one positive, one negative. Because there could be some of them where they're so big in either direction, we're going to have to do it multiple times. Now with negative 510, I could have started off by subtracting 360 from it and got negative 870 degrees. Is negative 870 still a coterminal angle? Yes. And it would still be a correct answer. I will check all of them. Not all of them, but I will check the ones that you have with it and make sure that they do work. And if they work, you get credit for it. If they don't, you don't. But instead of, if I'd have subtracted first, I would have got negative 870. I added, it would have given me negative 150. It doesn't count as our positive. We have to add it again. So there's different ways to get it. Questions on any of this here? Find the supplementing complement of each angle if possible. Supplement adds together to be pi or 180. Complement adds to be pi over 2 or 90. The main way I remember these is that complement, you're just complementing someone, you're kind of going about halfway. Supplement, you're actually supplementing, you're doing an actual amount, you're going all the way to actually helping them. So 180. That's the way I kind of try to keep them straight. Supplement, you're helping someone out, and you're supplementing, you're going all the way to help them out. If you're trying to help someone out with a complement, you're going about halfway. Not really supplementing anything, just giving a compliment. Let's look at 11 or 12. Which one do we want to look at? 12. 7 pi over 18. So to find the complement, we're going to subtract it from pi over 2. Now you can do this in a calculator. Pi over 2 minus 7 pi over 18 is pi over 9. If you get a negative answer, it's not possible. There is not one. Because the two angles have to be positive. And we'll do the same thing with pi. I believe it should be 11 pi over 18. We get these here. That's mainly just subtracting 7/18 from 1, or subtracting 18 or 7 from 18. But if you wanted, there's no reason not to plug it into the calculator. 91 degrees. So to find the complement, we subtracted from 90. Well, what's 90 minus 91? -1. So is there a complement? No, none. Because this is not it. This is our complement. This is our supplement. Yes, because then we can do 180 minus 91. So questions on complement or supplement? Convert from degrees to radians or radians to degrees. If we have a degree measure and we want to go to radians, we multiply it by pi over 180. If we have radians and we want to go to degrees, we multiply the radian measure by 180 over pi. That's it. 45 degrees, well, we do 45 times pi over 180. Pi over 4. Six pi over 5, we're going to multiply it by 180 over pi. I think it was 6 pi over 5, wasn't it? Okay. It is 216. Questions on any of this here? So, alpha y equals enter 6 pi over 5. There is a way to convert this to radians in the calculator, but I'm going to show you this here, show you how to do it. I would not advise it because multiplying it by pi over 180 or 180 over pi is simple, it's quick, it's easy already. Doing it in the graphing calculator is possible. One, if you're going to degrees, the calculator has to be set up in degrees. So it's making sure it's set up in degrees. So then we've got to go through the somewhat arduous process of actually typing the thing in, because fractions are not always the fastest. So we got to make sure it's the correct form. We get it as 6 pi over 5. The next thing we have to do is go second angle down to r and hit enter. Because what we're saying is that this unit, 6 pi over 5, is in radians. And if we hit enter, it'll convert it to degrees. But most likely, the time it takes you to 1, make sure it's in degrees, type the fraction in, then go find r. You could have just used the other calculator and multiplied it by 180 over pi and been done. And going the other way from degrees to radians is not always nice because of pi. So I could mode, go down here to radians, second quit, 216 second angle degree, we get this. If I divide it by pi, we get this, and I can say math, enter, enter. Okay, it is indeed 6/5. We can put the pi back in there. That's even longer than just multiplying 216 by pi over 180. So it is possible to do them in the graphing calculator. I would not advise it for these. They're a lot easier elsewhere. And as we go through trigonometry, you'll see there's a lot of things that calculators do really well at and are very simplified down from what we can do otherwise. And then there's other areas where it's painfully not. Convert to D, degrees, minutes, seconds. Negative 0.9225. So we can plug this in. Second angle, arrow DMS. This is one that it actually is a lot faster. Enter. Negative 0 degrees, 55 minutes and 21 seconds. The calculator will do this nice, easy, and quickly. Questions on this here? Just so you know, I'm just allergic to anything and everything that gets off pollen of any kind. Any and all dander, dust. So everything around here. I'm allergic to cats, dogs. I didn't even know you could be. I'm allergic to horses. Yeah. My allergies have a field day whenever I step outside. Yep. Yeah. Got it. But that's it. So how do we feel about 17, 18, and 19? We're just plugging them in, letting the calculator do it. Because we could go through the process of 232 degrees, 0.1325. 325 times 60. Okay, 7.95. 7 minutes. 0.95 times 60. Not 61. 57 seconds. So we get this here. Because we're multiplying by 60, the decimal by 60 each time to get here. Now, will every angle always end in a nice seconds number? No. So we do have some seconds that do have decimals. And in most cases, they may or may not round it off or approximate it. Because at that point, especially with a map, you're close enough to wherever you're trying to get to, you can find your way from there. Especially if you have two coordinates crossing over the top of each other. Convert to degrees, from degrees to degrees, minutes, seconds. Yep, so what we would do if we were doing this by hand is we would first divide the seconds by 60. Add that decimal number to the minutes. Divide that entire number by 60, and then add that number to the degrees. The other way we could do it is I could divide, add 47 to 45 over 360. But the seconds, we had to divide it twice, yes? So we'd have 60 times 60, or 3,600, because 60 times 60, 6 times 6 is 36. We have two zeros, 3,600. We could type it in like this and add all that together, or 47, 45, 45. I can grab the graphing calculator. 47 second apps degrees. 45 second apps minutes. 45. This time we can't go into the apps at angle. We got to go into the catalog. Seconds, enter 47.7625. That's it. Questions on this here? Yes, let's see here. I got rid of those. I fixed the test because that was on the previous iteration of the test. I made it and fixed it so that it didn't do that. So you don't have to worry about that. Okay? So all of them should end in a nice decimal or in a nice degrees, minutes, seconds. So we'll get some nice numbers. But yes, we would either put the bar to show that it's repeating or round to 2 or 3 digits. And that would only be for degrees, minutes, seconds on the seconds. Does that make sense? All right. 23, 24. Now, 23, because how many of them do we have? 23, 24. I'll look at 24. 23 is a little tricky. I think I removed it from the test. It's tricky in how it looks, but it's not actually that tricky. Because we could go through the process of finding the value of r, but the value of r actually works out to be 1, so that's opposite hypotenuse. So I'm going to look at number 24, because we do need to find the length of this hypotenuse. It is not 3, actually. Because what it is telling us from this point, we can look at it in one of 2 ways. Cosine comma sine. This length is -7 and this length is -5. So for it to be 3, if that was going to be the hypotenuse, the other 2 sides have to be smaller than it. So the distance, that hypotenuse is always the biggest side. So it has to be bigger than 7, even if it's by 0.0001. And nanomicron, this just super small, bigger, it has to be the biggest side. Now, so it has to be bigger than one of these. Now to find it, I'm using R. You can use A, B, and C, where C is the hypotenuse length. But we're using A squared plus B squared equals C squared. We take the square root of it. Now, okay, I'll show you this in 2 ways. And if you're wondering, yes, I did actually flip those from how I wrote them. The nice thing about addition, it's always closed. We can add any 2 things in any order. So when we do this, we get the square root of 74, yes? Whenever we square a negative number, it's always going to be what? Positive. It's always going to be a positive number, yes? So a lot of times, this is just me personally. I know that -5 squared is going to be a positive number. I know that -7 squared is going to be a positive number, yes? So that's not actually how I would write it in the calculator. I'd write it this way. I know that negative is going to simplify out because of the properties of squares. 74. We get the same thing. But cubes, or odd degree powers do not do that. They still stay negative. So be careful with that. If you feel uncomfortable doing that, don't do it, because the parentheses do not take anything away from it. So if you're not sure if you do need to remove them or not, 74, leave them. If you're not sure, leave the parentheses, because it doesn't hurt. But if it ended up being a cubic or something else and you dropped them, it might cause an issue. Does that make sense? There's some cases we can just remove the negative and the parentheses. And there's not very many with especially just straight squares that we don't, or that we do have an issue. But we get the square root of 74. Now sine of this angle would be the opposite side over square root of 74. We can't leave it this way. So if you want in the calculator, we can say -5 over second square root 74. Let it do it for us. Get this here. Cosine adjacent is not 4. -7 over the square root of 74. For this one here, if we plug it in, we actually incidentally get -7 square root of 74 over 74. Trying to remember if it's asked for all 6. Okay. Tangent is opposite over adjacent. -5 over -7. Well, the negative and negative make a, so it's just 5/7. Now at this point here, I'm going to go cosecant first. Because cosecant's what? 1 over sine. We're just flipping sine, yes? Well, we can flip -5 square root of 74 over 74. But that's going to give us a radical in the bottom, yes? So this here is, as we can say, 74 over -5 second square root of 74. And get this, and it's going to throw a fit. Because it doesn't like it. That's a really big radical. Now, what was it before we flipped it and rationalized it? It was -5 over the square root of 74, yes? If I flip that, we get what? Negative square root of 74 over, yeah, square root of 74 over -5 or negative square root of 74 over 5. Is the radical still in the bottom of a fraction? No, it's up in the top. I don't have to rationalize. It's done. Secant of theta. I'm going to do that again. If you end up with a radical as the hypotenuse, I would first, well, let me say 2 things. One, if the radical is the hypotenuse and is asking for all 6, I would set it up, -5 over square root of 74, as those first, then rationalize it in the calculator, then you're done. Because secant, cosecant's a little bit easier before we rationalize it, to just flip it and be done. Now, cotangent is the nicest one out of the group. That is just 7 over 5. There is no radicals for this one, and we are done. But that's it there. Now, if it asks for just sine, cosine, tangent, we can go on and rationalize it, plug it in, be done, because there is no reason to flip them. Questions on this here? We'll finish up with these here. Evaluate for sine, cosine, tangent. 7 pi over 4. If we wanted to do this, quote unquote, by hand, we can add 2 pi to it and get pi over 4. At this point here, I would get the unit circle out, let it do the work for me. And see that sine and cosine are both square root 2 over 2 in the first quadrant, because that's where pi over 4 is. For both, all 3 of these are positive. So tangent, right, and that's a good point to point out, is the same as sine over cosine. And if sine and cosine's values are the exact same, they're dividing by itself, so it's 1. So our 45-degree angles, or our multiple, because we've got 4, the sign of tangent will change, but it'll still be positive or -1. So 45, so pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4. Those 4 and any coterminal angles from those 4, adding 2 pi to them, will give you a value of positive or -1. Radians, sine of -7 pi over 4, 2 over 2. plug it in a calculator, let it do it for us. Questions on this so far? I think we're about halfway through the review sheet. We're about out of time.